Good morning students. Today we are going to discuss IIT-JEE NEET Foundation. See, the topic is in the Newton's laws of motion. There is a force and the types of forces. See, force is nothing but a push or pull acts on a body which changes or tends to change the state of rest or uniform motion of a body. If the body is acted by some push or pull, so which can change its position or it can trying to change its position, so like state of rest or uniform motion is called force. See, the types of forces and force, the formula for the force is mass into acceleration. See, the formula for the force is mass into acceleration. See, the force, the term force which has comes from the Newton's laws. Newton's law, first law defines the force and second law which can measure the force. So the first law, every body continues to be state of rest or uniform motion unless compelled by an external force. Second law, the acceleration is directly proportional to force and inversely proportional to mass. And force equal to, see, mass into acceleration. Force equal to mass into acceleration. The rate of change of momentum. The rate of change of momentum is directly proportional to force. So change of momentum nothing but final momentum minus initial momentum upon time. See, final momentum is mass into final velocity and initial momentum is mass into initial velocity upon time. So mass into change of velocity upon time. So the change of velocity is, rate of change of velocity is acceleration. So force equal to mass into acceleration. So this is about the force formula and the force units. The unit of force is newtons. 1 Newton is 1 kg meter per second square. Newton is SI unit. The CGS unit of force is dyne. The dyne, 1 dyne is 1 gram centimeter per second square. 1 Newton is equal to 10 power 5 dynes. 1 Newton is 1 kg meter per second square. So kg is nothing but 1000 grams and meter is nothing but 100 centimeters upon second square. Gram centimeter per second square is called dyne. So that is 10 power 3 into 10 power 2, 10 power 5 dynes. 1 Newton is 10 power 5 dynes. Newton is the SI unit of the force and dyne is the CGS unit of the force. See, coming to the topic, today's topic is the force definition. The force is which can influence that the causes of the object undergo change in its motion, which influences causes of the change in the motion. It also describes the push or pull or interaction between the two objectives. The force can be, see, the force is a vector quantity. That also you have to remember. Force is a vector quantity which is having magnitude as well as direction. See, if you are saying so force, some force, so definitely you have to specify the direction also. It's a vector quantity which is having magnitude as well as direction. The units of force are newtons. The in SI system and the dynes is the CGS system. The examples of the forces like gravity, friction, etc. and viscous, all these are the different forces, tension. So this is about the definition of the force. See, coming to the types of forces, what are the different types of forces are there? See, the gravitational force and another one is frictional force, normal force and tension force, applied force, air resistance, spring force, etc. There are many types of forces are there. Many types of forces. So in that, among some of the forces are gravitational force. What is gravitational force? The gravitational force is nothing but, see, the earth gravity, the pull of earth gravity towards the object, we will call it as a gravitational force. See, the earth can pull the objects towards center of the earth. That is nothing but the gravitational force. This gravitational force is only an attractive force. Gravitational force is only attractive force, no repulsive force for the gravitation. And weakest force in the nature. In the nature, the weakest force is gravitational force. When you compare with electrical force, magnetic force and nuclear force, see, usually the nuclear force is the strongest force and compared to electrical force is 10 power 36 times of gravitational force. So 10 power 46 times is than gravitational force, nuclear force. Nuclear force is the strongest and weakest is gravitational force. See, the gravity is only attractive, but electrical force, magnetic force, it can be either it may be attractive or repulsive. Attractive or repulsive. So there are the forces in the nature. These are all natural forces only. So the natural force like gravity, gravitational force between any two masses. The Isaac Newton has discovered this. So something like gravity, earth has got the power of gravity. The famous experiment, falling of apple, okay, so earth gravity and acceleration is also there for the masses. The larger mass have lesser acceleration and smaller mass have more acceleration. Acceleration is inversely proportional to mass. All these things are so coming under the topic of gravity, gravitational force. Coming to friction, see, there is a contact force, friction. So there is a between the two surfaces, so there is a force which is applied against the motion of the object. See, the force between the two surfaces which acts against the motion of the object is called frictional force. See, friction is also very important force in day to day life. So something like friction is having advantages as well as disadvantages. Friction can wear and tear the machine parts, and you can take friction also helpful whenever you need, if you want to walk or run, all these things are possible. You are able to do some work or playing, all these are possible due to the friction only. Somewhere advantage, somewhere disadvantage. That's why friction is both necessity and enabling. Sometimes it is very helpful, sometimes it may be disadvantageous for you. See, coming to the another force, that is normal force. Normal force is nothing but it's a force which acts perpendicular to the surface of a body. The force which acts perpendicular to the surface of a body, it is called normal. The normal means it is something perpendicular. So where the force which is going, for example, gravity is there. The gravitational force, you take the gravitational force which will be acting downwards, the weight of a body you take. See, let us take object is there. So some object is there. The gravitational force will be acting, that is W. Opposite to the gravitational force, there is a force which acts, that is normal force. Normal force is some perpendicular force to the object, or so that we will call it as a normal force. It's a contact force. So whenever object is exerted by the some surface. See, coming to the next one is tensional force. What is tension? See, the tension is nothing but the elastic restoring force of an object. See, in the strings, etc., there is some restoring force which can balances the weight of your body. That restoring force we will call it as a tension. The force that transmitted through the some ropes, cables, etc., that we will call it as a tensional force. That's why tension in the string, the tension in the rope, all these we are going to, and if a rope is passed over a pulley, there is a tension which is there, and one end is connected to object and other is hanging object or something. So this type of problems comes under this tension. The tension is also another type of force. See, there is a applied force. Normal human being, you are applying some force on object, so or something, that is applied force. So air resistance or drag. Air resistance, there is some air wind also which can oppose the motion of the object. That is also one type of force which can resist the motion. The spring force, there is a spring also exerts some force. So elastic, the something like compression of a string or extension of a spring which can release certain force, that we will call it as a spring force. See, these are all the different types of forces in the nature we have types of forces. See, contact force, the contact force whenever there is an object, so or contact with another thing. So when object comes into contact with each other, there is some force which is going to be exert each other, so that we will call it as a contact force. The contact forces are basically, it may be either attractive or repulsive. So examples of contact forces you take, there is a frictional force, normal force, and air resistance. All these are the different examples of the contact forces. And see, the frictional force I explained just now, the frictional force between any two surfaces, the frictional contact will be there, that relative motion which opposes the relative motion between the two objects. So the frictional force and a normal force which is perpendicular to the surface of the earth, and tensional force, all these are also comes under the contact force. There is a transmitting, so which is going to be there inside the ropes and other things. So another is elastic recoil. What is this elastic recoil? Elastic, see, some elastic restoring force. See, there is some objects, all the objects made up of atoms and other things. So there is between atom to atom or some elastic energy which is there inside the, so the objects, what that elastic recoil. See, elastic, the tendency of the strength like a compression or a extension, so that returns into original shape. So whenever there is a, you take rubber, elasticity is a property which is going to be, it's a property of matter. See, whenever it's a by virtue which retains its original shape after, okay, you are applied on it, so that is called elastic recoil. See, it retains its original strength, like, see, compression or, okay, see, you are extending the thing, okay, extension, compression, all these comes under the elastic recoil. This phenomena comes under the elasticity. The property of elasticity, plasticity, these are the properties of the matter. See, coming to the next, when the elastic object is stretched or compressed, it stores some potential energy, elastic potential energy. So that elastic potential energy, so which gives the, that is directly proportional to the deformation of the object, how much it is going to be there. When object applied by the force or you remove the force, it return its original shape or size. In that process, there is certain energy which is going to be released, that elastic potential energy, which converts into indirectly kinetic energy. So that can do the motion or which can resist the motion, etc. This is type of, okay, so what we will call elastic recoil. Elastic recoil. And the tension force. See, just now we discussed tension force is another types of force due to the some, so whatever the energy transmitted through the ropes and other things which is trying to, inextensible strings or etc., those are executes this tensional. So the tension arises whenever force is applied to the connecting bodies. Okay, so tension is going to be balances that weight of one object. So, and tension depends upon the length of the string, what you use, length of the rope and etc. Those are all the, so tension, see, tension is directly proportional to, so object here, the mass of the objects, whatever it is. Okay, so that all we have to take into consideration. So the tension formula, normally it is like a force only, so we are going to discuss more clearly in the strings and the ropes, etc., connecting bodies, there it will come. So another force is buoyancy. What is buoyancy? Buoyancy is the upward force in the liquid. There is certain upward force. The liquid also exerts some force. If an object is trying to immerse into the water or immerse into the liquid, there is certain force which acts opposite to the weight of a body. So when body is immersed into the liquid, there is certain, okay, so upward force or upward thrust which is going to act on the object, that we will call it as a buoyancy. Buoyancy is the upward force exerted by the fluid when a object is partially or fully immersed into the liquid. So the difference of pressure in the fluid which makes the body to move okay, so in one side particular direction, that is buoyant force. The buoyant force which acts on the object, see, depends upon the how much volume is displaced in the liquid, how much volume displaced by the liquid, and also which depends upon gravity and other factors. So when object, this means more fluid if you displace, more upward force is going to be there. So that weight of fluid displaced, any floating body, for example in the physics there is a law of flotation is there. Flotation depends this buoyant force. See, the weight of an object is equal to the weight of a liquid displaced. So the weight of object is supposed to be balanced by the weight of liquid displaced, then only body can float on it. If there is a more buoyant force is there, so definitely the body is going to float. Okay, so if there is a less buoyant force is there but gravitational force is more, weight is more, then it is going to immerse into the liquid. So it will be submerged into the liquid. So that is called buoyancy. Buoyant force, this is another type. And a spring force, there is a spring force equal to F is equal to minus kx, the spring force formula, F equal to minus kx, where k is the spring constant. So this spring force also depends upon extension of a spring. See, the spring force also depends upon extension of a spring, and so it is also a contact force which is stretched or compressed, so executed. See, whenever you are compressing a spring or etc., so those cases we are going to have the spring forces. It's a type of contact force. See, in the spring force one important law will come across, that is Hooke's law. Just now I told you F is equal to minus kx. Robert Hooke is the scientist. He has given the force is directly proportional to extension of a spring. Force is directly proportional to extension or displacement of a spring. So this law is very F equal to minus kx. F equal to minus kx. So this formula we use in the mechanics. So the force is directly proportional to displacement. F equal to minus kx. So k is called spring constant, x is the displacement or extension of a spring. See, coming to the weight. Weight is another important, okay, so force. It's a gravitational force exerted by the body. The pull of earth gravity, that is called weight. The gravitational force, the weight is the force of object due to the acceleration due to gravity. What is the formula of the weight? Weight equal to mass into acceleration due to gravity. Weight equal to mass into acceleration due to gravity. W equal to mg. W equal to mg, where m is the mass of the object and g is acceleration due to gravity. The g value is approximately 9.8 meters per second square in MK system or SA system. So m is called mass and g is called acceleration due to gravity. The value of g is changes from place to place. The weight is also a vector quantity. So weight depends upon acceleration due to gravity. Gravity changes, so weight also changes. If you take on the surface of the earth and surface of the moon, so there is a 1/6 of the weight will be there on the surface of the moon, because the gravity is 1/6. The gravitation, earth gravity, that is acceleration due to gravity on the moon, is 1/6 times of acceleration due to gravity on the earth. So g value on the moon is 1/6 of, so hence weight also 1/6 of. So here weight, for example, you are 60 newtons on the surface of the earth, so that 60 newtons so may not be on the surface of the moon. 1/6 of 60, that becomes so 10 newtons only. So there is a difference when you are where that location is also important. So g value depends upon many factors, at what height from the surface of the earth, or what depth from the surface of the earth, or at what latitude or altitude. All these things are okay, so depends the acceleration due to gravity. So that's why weight also changes from place to place. Weight measured by the spring balance, or weight is a vector quantity. So weight is also another type of force. See, coming to the next. So these are the different types of forces. So thank you very much. We'll continue in the next video.